Hello friends, welcome to Power Electronics. Today we will discuss the class B commutation, which is also known as resonant pulse commutation. For explaining class B or resonant, you can watch in the diagram. In this diagram, you can see Vs is the source voltage, T1 is the main thyristor, Ta is the auxiliary thyristor, where C is the capacitor, L is inductor, Ic is the charging current, polarity is marked. This is the diode and this is the load current. I naught is the current which is flowing equal to I naught, that is load current. So what happened before the before the triggering of the thyristor, the source voltage Vs have charged the capacitor. How it is charged? This current flowing from this part here, it flows, then it passes from here and this charge to the capacitor to the source voltage Vs. Before turning on it, before triggering the thyristor, it was already charged. So now what happened after that? Now this the thyristor T1 is working. T1 is working. When the thyristor T1 is working, this current flows from the thyristor and it passes towards the load and having a return path. So after that, the current is normally flowing. The question arises why this charged capacitor do not flow from this path to this thyristor. The reason is that this source voltage and this capacitor voltage is same. When the potentials are same, then it has no current. No current can flow. Only one path is available, that current flows through this thyristor which is shorted, and the current passes through the load I naught. You can see also in the diagram that when the gate G1 is IG1 is triggered out, the what is the condition of load current? Load current is almost constant. So current flow from this path to the load and it is constant. Condition of thyristor T1. T1 is also constant because same load current flows through it at that a particular point of time, at that instant. About the charging current. The charging current has no path to flow because this voltage, the supply voltage and the capacitor voltage is same, so the charging current is 0. The condition of capacitor. Capacitor was previously charged to voltage Vs and it has no path to discharge, so it will remain as Vs up to the instant t1. After the instant t1, when we triggered out the thyristor Ta on, this auxiliary thyristor was on. Now what happened? Now here the situation changes. What happened now? Now this when this auxiliary thyristor is triggered out, this capacitor now gets a path to discharge. It discharges through this path to thyristor to this inductor and capacitor as a return path. So I will remove this and explain again. When the this thyristor was working, the current flowing from this to load and this. Now the capacitor have got the path to discharge. It discharges to this path to auxiliary thyristor to inductor and capacitor. After one cycle, the polarity gets changed. It becomes plus and minus. As you can see in the diagram, that load current is almost constant. Load current has no change because thyristor T1 is working fine. And second, the current through the thyristor T1, that is also the same. That is also constant because same as the load current. If we see the charging current, this charging current has a reverse path. That is why it is rising in the negative direction and rising to the maximum value. Capacitor discharge through this auxiliary thyristor and through inductor. Also we can see that capacitor discharges. Here capacitor was charged previously to value of Vs, then capacitor start discharging and reaches a value of 0. At that particular point of time where I have marked, the capacitor polarity changes from plus minus, which was previous, to minus plus. Now the capacitor has make this thyristor, auxiliary thyristor, turn off, because this is minus sign here, minus sign is given to here and plus here, so that means this auxiliary thyristor gets turned off. So where the charging current will flow? Charging current will flow here. From here plus minus, charging current will start flowing here and pass through the diode and move towards the thyristor T1. Again, one question arises, why current do not flow through the load and just passes through the thyristor T1? Reason is the charging current. Charging current is higher than the load current I naught or small I naught. So you can see by the diagram that how this the situation of the capacitor changes. It will start this polarity of this charging current changes, because previously it was flowing from the thyristor Ta to inductor L and capacitor. Now it changes from the capacitor, inductor, diode and T1. So it starts rising. Here it starts rising to a value of 0. And situation of capacitor, what happened to capacitor? It's again start discharging through the diode. It was previously 0 and it rises in the negative direction because polarity changes, and it reaches a value of this VAB at instant T2, where the auxiliary thyristor is turned off. Why? The negative polarity here and positive here. After the instant T2 to T3, what happened? The charging current make this thyristor T1 turn off. Why? Because this pass through this capacitor, this SCR, and make this turn off. As you can see, it starts making turn off, rises and reaches a point this. At that particular point of time, the thyristor T1 is off. Now what happened to this charging current? Charging current is almost again constant, behaves at constant I naught. So from T4 to T5, what happens again? This capacitor, same situation becomes here like the first instant. Now what happened again? This is turn off, this is turned off, this is also turned off, this is main thyristor, this is auxiliary thyristor. Now again the current flows from this path and charging the capacitor to the source voltage Vs. As you can see, this capacitor rises and make this voltage constant at that particular point of time. After that it becomes constant. You can see there is a sharp rise because this source voltage is charging this capacitor. When it is charging, look at the condition of charging current here rises and become constant. Also you can see the thyristor T1 at the instant T3, at the instant this T3. Look at this, the thyristor T1. This charging current IC which was flowing here has make the thyristor turn off. It make its value 0 and it became off. So load current, again that same situation arises, load current became constant. So Vs again became the same. As you can see in the first diagram, same. The capacitor has the charging current, the thyristor starts again working, and the load current is of same. This cycle repeats again and again. This is the easy explanation. So what happened here, the as a thyristor is commutated by the gradual buildup of resonant current in the reverse direction, this method of commutation is called as current commutation or called as class B commutation or resonant pulse commutation. Now what we have discussed, the charging current IC. What is the charging current? As we have already discussed, it is minus Vs under root C by L sine omega t, where omega naught is the resonant frequency. As we have discussed, this is of tank circuit value that we have applied the KVL in the previous class, and we have seen that, as you can see here. I will show you. It was available here. Okay, we will discuss another day. So how this works? This is the charging current. This is its value, and this is the minus IP, the peak value of sine omega t. I hope you understand. Thank you very much.